what the internal length of the swan is. Let's go ahead and take a closer look at our pulmonary artery catheter lines that we have here. You have quite a few. You have 3 that are going to connect to your monitor. This will connect to the Vigilance 2, or it will connect to the hemisphere, and it's just whichever machine you're able to grab. If you're able to grab the hemisphere, go ahead and grab that first, and then go for your Vig 2. Another 3 you'll have which connect to, 2 of these will connect to your pressure line setup. One of them you can use as a IV infusion port. So the blue one here, if you're guessing CVP, you are correct. Blue is consistent with what's going to be on our pressure line setup, the cord that connects it to the monitor, and on the monitor what's going to pop up. So that's going to be your CVP. You have your yellow. When you connect this end to a pressure line setup, connect it to the yellow cord goes into your monitor, you're going to get your pulmonary artery blood pressure. Your white port is your proximal infusion port, and that's proximal to the insertion point of the catheter. So this is going to be somewhere in your superior vena cava, maybe it's in your IJ, subclavian, etc. But you can give meds through here. You can give meds through your white or your blue. Do not give meds through your yellow, because that's going to go to your lungs, and we don't want medications to go into the lungs. We'd rather it go to the heart, so we're going to go to our blue or our white. The last port you have on here is your balloon port. So right now all the lines are lined up, so this means that the balloon port is open. There is a special syringe that attaches, and this will only go to 1.5 cc's of air. So you want to make sure that when you're assessing your patient, if they have a swan, you want to make sure that the syringe is empty. You can go ahead and unlock it. When you unlock it and detach the syringe, any air that is in your balloon that's wedging it will escape. You can get rid of that air, and you're going to go ahead and screw it on and lock it. So this is how your swan should look all the time. If you come in and it looks, like this, you may be wedging your patient, so go ahead and take it off, let the air escape, lock it, put it back on. And that is your lumens. Okay, so now I'm going to show you how to connect your swan to your hemisphere. The hemisphere is the new cardiac output monitor, the newer version of the cardiac output monitor that we have from Edwards. The power button is in the front. The power cord is connected in the back of the monitor. If this is plugged in, you're going to see a nice orange yellow color on the power button. We're going to go ahead and press power on. It's going to turn green. To note, on the right hand side of your monitor, you are going to have your normal values with the reps numbers. So if you ever have questions and your super user or your charge is not able to answer those questions, go ahead and call the reps. So right now it's going to be doing a self-test. On the right hand side of your monitor, you're going to have your cord connections. 2 cords are needed to connect your swan to the monitor. The first one is going to be your gray end, which aligns of course with what your monitor has here. So I'm going ahead and plug that in. And then same thing with your other cord, has a perfect spot for it to go as well. And the ends of these cords look like this. So you're going to have these ends to your cord. So I'm going to go ahead and show you how to connect those now. So we have the end of our swan. Your blue clip is going to come in here, so we're going to go ahead and open that up. It's there. And then it's closed back up. So now this is in place, it's secure. I'm going to take my other ends here, and all the colors are going to line up. I'm going to go ahead and place these in, and this will go ahead and screw on. So I'm going to push that in and then screw it on. There you go. So again, you could unscrew this, take it out. The arrows are going to align here, and I'm going to screw that back on. So don't be pulling these out. But now all my connections are made to my monitor. So when you turn on the monitor, it's going to give you the option to add a new patient or continue the same patient. If it's been 72 hours since the patient has been on this monitor, it will just show new patient. I'm going to go ahead and press new patient. When you do that, it's going to ask you to put in a little bit of information. You're going to go ahead and put in the patient's ID number, their height, their weight, age, gender. What you'll be doing here is essentially getting the body surface area of this patient. So I currently have this in demo mode. Essentially, after you connect your swan and you put in that information, all you got to do is go ahead and press the go. After this point, it's going to take about a minute for you to get your initial readings. Similar to your EV1000, you're going to have the option to change your screen. So if I wanted to change my screen, I would come over here. I could choose, whichever figure I wanted to look at. This is a popular one because you get to see the cardiovascular system. Another screen that I find is helpful is this screen here, which is going to give you your trends of the patient. So you can, if you haven't updated your flow sheet, you're behind, you can come back here in time and write all those values down. So let me go back here. If you wanted to change the number of values that you see on your screen, essentially you would go back here and you could choose 1, 2, 3, or 4. So I'm going to go ahead and press 4 and go ahead right there. So right now I have it set to give me my cardiac output, cardiac index, and this SCO is your stat cardiac output. This cardiac output will be popping up every 5 minutes. This stat cardiac output will happen every minute. So I definitely recommend, if you don't have stat cardiac output on this monitor, that you put it on there just because it's going to give you the value more frequently. At the bottom of the screen, you're going to have your date, your time. It's going to have your core body temp. Now I will show you how to calibrate. So calibrate is going to be under this clear marking here. You're going to go to your nurse's bag and you're going to do oximetry calibration. So when you're doing oximetry calibration, essentially what you're doing is you're going to calibrate your SVO2. Your SVO2, just think of it as, if oxygen is a passenger on a train, the train is the blood. The blood picks up the passengers, the oxygen, at the lungs. It carries it over to the cells, drops it off. Some of the oxygen will drop off the train at the cells, but a majority of it will remain in the venous system. So your SaO2 is, when you're explaining it to your patients and their family members, your SaO2 is the percent of the hemoglobin that is saturated with oxygen. Rather, your SVO2 is the percent of your hemoglobin that is saturated with oxygen, but rather in the arterial blood with your SaO2, this is in the venous blood, your SVO2. So how you get your SVO2 calibrated is you're going to go to your nurse's bag, you're going to choose oximetry calibration, and then you're going to go to in vivo calibrations. It's then going to do a 25-second calibration. At this point, you are going to be getting a ABG syringe from your RTs. You're going to be drawing blood from the yellow port on the swan. When you're going to draw your blood from your swan, you're going to go ahead and press draw. At that point, then, it's marking when you drew your SVO2, clearly here, the time. Your RT is going to run your VBG, and you're going to get the SVO2 off of the ABG. You will need to have a current H&H to do your oximetry calibration. So I'm going to go ahead and put in those numbers. We're just going to say, 21%. Let's say our SVO2, this was 65 on our VBG. Now we're going to press calibrate. It's going to take 25 seconds, and then after that, you'll be getting continuous SVO2 on your monitor here. So now, as you can see, I got my SVO2 running continuously. On my SVO2, I can see there is 4 boxes here. Got 1, 2, 3, 4. If I have 4 boxes filled up, essentially what that means is I'm not getting an accurate reading. Maybe the end of my line is on a vessel. Maybe the cord is just reading inaccurately, it's an old cord or it's an old swan, and so it's not reading accurately. What you're going for is that 1 to 2 boxes. 1 to 2 boxes means that it's going to be accurate.
EV1000, this is your monitor, this is your data box, this is pretty much your brains, and this is your pump that supplies the power. This has the ability to do minimally invasive with the flow track and non-invasive with the ClearSight technology. In order to turn this EV1000 machine on, you literally, there's a button on the back, you turn it on. While it's turning on, what you're going to see is it's going to take a couple minutes for it to actually warm up or prompt. At the short term of that, what we want to do, the next thing is we're going to actually show you the simplicity of putting it on a cuff. And this is the ring sizer. This is how you're going to actually measure what size cuff the patient gets. Here, we're going to actually see he is a medium. And as you can see here, they come in 3 different sizes: small, medium, and large. So with him being a medium, we're going to use a medium cuff. The importance about this cuff is this cuff has a light sensor, light diode, and an actual bladder in the middle. So you want to place the finger between the 2 middle green lines there where the 2 arrows are. At that point, you want to roll it and actually clamp the finger cuff on. You are done with the finger cuff at that point. The next one is we want to always start up with a new patient. We're going to hit new patient. At this point, it is going to ask you for the patient's BSA. The height, 71 inches, and you can do inches or centimeters. We've chosen inches. We're going to do weight, which can be done in pounds or kilograms. We're going to do pounds, 200 pounds. We're going to do age. We're going to do and gender. This is all important for the BSA, and this is going to compute the numbers that it compares to in your data box here. So at that point, you're done. Now it wants you to zero this out. Into zero, you're going to take the heart reference sensor end of it and the finger end of this. This is basically a transducer. You're going to zero these 2 out by putting them together and pressing 0. It is 0. Once upon zeroing, you're going to take this end, the finger end, and connect it to the finger slot here on the slot. Once connected, this will go at the heart level. The heart reference sensor will go at the heart level. Here, the cuff will go here, and we will plug in the cuff into the pressure cable. At that point, you see a green light here, green light on the pressure cuff. The next step is just to start it. Hit the start button. You are actively now getting information from using a ClearSight non-invasive technology on the setup. Now you hit the home screen, you get a chance to use all the parameters you want. If you ever want to change between technologies, you hit this little button here that allows you to change between FlowTrack and ClearSight. You know, choose FlowTrack, you go here. Do I want to switch? I'm not going to switch because I'm still using non-invasive. But if you ever need to switch technologies, the little grayed out area here. So now we're back in the ClearSight. Now you just enter your menu where you choose which menu screen you want to look at. And that's based on the doctor's preference. So here, quick and easy ClearSight setup.
The Starlight SV provides continuous, accurate, non-invasive hemodynamic monitoring and empowers fluid management in virtually any clinical setting. It utilizes bioreactants, a technology that was developed by Cheetah medical scientists over years of research and development. This was then followed by extensive testing and validation. The basis behind the Starlight SV is the use of time delay or phase shifts, which occur when an alternating electrical current is passed through the thorax. The Starlight SV has 8 sensors on 4 sensor pads. 4 outer sensors emit a low-level electrical current, and 4 inner sensors detect the information and send it back to the monitor. As the heart expands and contracts, a time delay or phase shift is created in the current by blood flow. The monitor then uses this phase shift as a baseline for measurement. To determine fluid responsiveness or volume status, a fluid bolus is delivered. If the heart can receive more fluid, we'll see greater outflow and a longer time delay, equivalent to the increase in stroke volume. If the stroke volume increase is greater than 10%, then the patient is determined to be fluid responsive. This is also represented on the Starlight SV monitor by the estimated location of the indicator on the Starlight curve. Its location will appear on the steep ascending portion. If it's less than 10%, the patient is considered not to be fluid responsive. The indicator will be approximately close to or on the top part of the Starlight curve. Although the technology is highly sophisticated, the Starlight SV is easy to use.